So in summary, we often iterate over items in a sequence. Later we will see that these things that we iterate over don't even have to be sequences. For now we have seen things that are sequences, lists, strings and tuples, but later we will see a more advanced data structure called a dictionary, and it turns out you can iterate over the items in a dictionary as well, even though that is not a sequence. Now often iteration is more efficient than recursion. And in some cases where you can make use of this idea of comprehension, like we have seen with list comprehension, that can be even more efficient. But I don't want you to take away from this that we should always use iteration. Remember, recursion is a very powerful idea in computing. This idea that I can write a function which calls a helper function which is itself. It sort of self-helps. And this idea of recursion can be extremely useful in certain cases. So it's important for you at least to be familiar with the idea of recursion, although many times when you want to write code, you might write that code iteratively. And when you do, there's a very good chance that that code is actually more efficient than the corresponding recursive code. We have seen two common patterns of iteration. There are others, but these two will get us started. The first pattern is to iterate until we hit some sort of success condition. When we reach that success condition, we may wish to return an answer, or we may wish to break out of the loop. If we fail to achieve success, then if there is an else condition associated with the if, we will go to that no break condition, and there we would typically handle the failure associated with pattern 1. And pattern 2 is a very, very common pattern. You will see this all over code, and the way you will recognize pattern 2 is you will see a variable initialized to some value. It's going to play the role of the accumulator, and then inside the code you will see that we will update that value in certain ways corresponding to accumulating some sort of answer. We have seen that for lists, the accumulator is typically initialized to the empty list, and then we append new items to it. We have seen that list.append is a very efficient way of adding new items into a list. And we must remember that the idea that our friend suggested, where they use the plus operator for list concatenation, can be very, very slow. There are times when you do need to use that operator. There are times when you don't want to modify the original list, and if you use list.append, you will modify the original list. Not the object, remember, that doesn't change, but its contents. And so in situations where you don't want to modify the original list, you could use our friend's idea. Remember also the difference between regular plus and plus equal to for lists. Now we have seen that these two patterns can be combined, and for example you can have an outer loop that has one pattern and an inner loop, a nested loop that has a different pattern. In our next lecture, we will continue our discussion of lists and list comprehension, but we will also try to develop a very, very important skill. As the code we write gets more and more complex, it will get harder for us to read it. As we get better, of course, we will be able to read that code. But right now we might be in this intermediate stage where we think we can write code that looks correct, but we really haven't reached the point where we can be confident that we have understood it. So how do we help ourselves? How do we build our confidence? Well, a simple way of doing this is to write good quality tests. We have already seen the doc test syntax. In our next lecture, we will talk about how we know if our set of test cases is of good quality. Is our set of test cases good enough to detect any potential errors that either we or our AI might have introduced into the code. So we will take a look at some problems that are a little bit more complex, and we will learn how to write high quality tests. See you in our next lecture.